Yeah. Okay, so 3B question 8, the question looked like this. Fx equal to x plus k over x squared plus k. So you need to, is decreasing for all values of x. So we know that, so if we say decreasing for all values of x, so this implies f prime x is always greater than 0. Okay, so this is how I interpret. This is the first interpretation I have. So now what I need to do, I need to get my f prime x first. So they say find the range of values could the constant k to satisfy this condition. Okay, so now I get my f prime x using quotient rule. V u prime, take away u v prime, the whole thing over v squared. So I simplify the top. So I got x squared plus k minus 2x squared minus 2kx over x squared plus k squared. So when I simplify this, I will get negative x squared minus 2kx plus k over x squared plus k, the whole thing squared. So from this here, so that means negative x squared, sorry, it means negative f prime x greater than 0. So negative x squared minus 2kx plus k divided by x squared plus k squared must be greater than 0. So we know that the bottom here, anything squared definitely is greater than 0. So for this whole fraction to be greater than 0, the bottom is greater than 0. So from here, I will conclude that this quadratic function must be greater than 0. Right? So that means if I sketch this graph, this is a quadratic. Right? The graph must be above. This is called, this function, I call this function hx. So, so my graph is wrong. Do you know why my graph is wrong? Can someone tell me why just now I sketched the graph is wrong? For a quadratic function, if, sorry, this is equal to negative x squared, correct? So the shape, because a is equal to -1, so the shape of the graph is this. Am I right? So in order for this to be greater than 0, your graph must be like that. Am I right? So you must have 2 x-intercept. Right? No. Is Miss Do doing the correct thing? Wait, okay, so I'm doing the correct thing. So that means it must have, so that means, which means that your determinant b squared minus 4ac must be greater than 0. Agree with me? Anyone? Okay, so your b squared minus 4ac must be greater than 0. So now, what should your value of k be? So it's 4k squared plus 4k must be greater than 0. So now you want to solve this quadratic for k, right? So you must draw the sign diagram for this function. Okay, so you have to find the x-intercept first. So k, 4k, k plus 1 equal to 0. So you draw the sign diagram for k, 0, hold on. -1 and 0, correct? Yeah, so it will be plus, minus, plus. So you take this part and this part. Okay, so k must be less than -1. But if you look at here, k cannot be -1. Do you know why? Because if k is can be -1. -1 or k is greater than 0. So this will be the answer for the question. Are you okay? Is that the right answer? I think the textbook answer is the other way around. They put in between, right? Many years students ask me about this. Any question? Okay, Anna, the person who asked about this question, can you get it? Okay, -1 and 1. Did I do any wrong? Did I make any mistake? Decreasing for all values of x. Yeah? Oh. I do the other way around already. Sorry. Decreasing for is decreasing for all values of x. So f prime x must be less than 0. What are you talking about, Mr. Less than 0. Okay, f prime x must be less than 0. Hello, Miss Do. Decreasing for all values of f prime x is always less than 0. Okay, less than 0. Why no one pointed out to me? So that means this one must be less than 0. Always less than 0. So b squared minus 4ac. So this is not the graph. Hello. So the graph should be, the graph of this hx should be this way. Negative. Right? So that means b squared minus 4ac must be, what is Miss Do doing? Less than 0, less than 0, less than 0. Okay, this one equal, so you take this part instead. So this is wrong. So k have to be between -1 and 0. Okay, so that's why the textbook answer is wrong. Can I? Hello? Is that okay? Yeah. Yeah, decreasing for all values of x. Yeah. Is that okay? So any other question? So this one is a bit tough. From here, you have to know how to analyze it. Okay, huh? So I get into what we want to do today. I'm going to give you another function. Then during holiday, you can go to TimesTen and download those questions on curve property, okay? And complete your exercise 3B, 3C, and 3D. Okay, so now, given fx is equal to x to the power 4 plus 4x cubed minus 16x plus 3. Okay, A. Find the coordinates of stationary point or points of y equal to fx. Okay. And state its nature. Okay. B, find the coordinates of the inflection point of y equal to fx and state its nature. C, sketch the graph of y equal to fx, y equal to f prime x, and y equal to f double prime x on the same axis. Okay, you may start now. I give you 10 minutes. You can either use your GC to help you, okay? And also do it manually for up part A and part B. Okay, huh? So when we talk about polynomial, look carefully, class. Fx is degree what? Degree what? Hello? Highest power is 4. So degree what? Chokan. Chokan. Hello.
Yes, yes.
Fx is degree. Polynomial got degree. Degree what? Degree what? Chokan?
Degree 4.
Yeah, degree 4. So f prime x is degree 3. So it will be 1 degree lower. So f double prime x will be degree 2. So look, we know that when I teach you polynomial, correct? I told you it's degree 4, maximum 2, 3 stationary point. Maximum. Okay? Maximum 4 x-intercept for degree 4, maximum. Okay. For degree 3, maximum 2 turning point, 3 x-intercept. Am I right? So these are the things about polynomial that you have to recap. Okay. So now I got my f prime x. So I want to find stationary point. So I have to put my f prime x, that is 4x cubed plus 12x squared minus 16 equal to 0. So you can use your scientific calculator to help you to get the answer. So you will get two answers, x equal to -2 and x equal to 1. Agree? Hello? So actually I should have 3. I said maximum 3 x-intercept, but here is only 2. So that means this answer is wrong. So now, if I want to know the nature of the stationary point, what must I do? Amanda?
Draw sign diagram.
You cannot just tell me sign diagram, Amanda. Sign diagram of what?
Oh, f prime x.
Thank you. So you have to be very specific. Sign diagram of f prime x. Yeah, so what must I mark on the line of this, on this line? What number must I state on this line? Espinderen.
Okay,
I must have 2.
okay, yeah.
What number must I put down here and here?
Hold on, yes,
The answer is on the board already.
just -2 and 1.
Yeah, because that make the f prime x equal to 0. So how am I going to determine the sign? I use my graphic calculator, correct? So your graphic calculator, now you are doing this chapter, you must always remember GC, your y1 is your fx. Your y2, don't delete, let it be like that. I mentioned many times already, and your y3, let it be like this. So from now onward, I'm not going to repeat. So you use your graphic calculator to determine the sign, and you get here positive, negative, negative, correct? So now, negative for fx means going down. You see, you go down, stationary, go down. So what do we call this point? This is my fx graph. So what do you call this point? What do you call this point? Huh? How to?
Local max.
This point I'm pointing here, how to be local max. I got, yeah, I should call this horizontal stationary inflection point, or stationary inflection point also can. Correct? And for this part, you go down, stationary, go up. So what do I call this point? What do I call this point? Jen Hao?
Local minimum.
Yeah, local minimum. So now you have 2 points. That is when x equal to -2, f -2. You go to your y1 and straight away get the answer. Can someone give me what is the answer? Alpha trace y1, you put in -2, 19, correct? Hello, you don't have to show your substitution. So therefore, -2, 19 is stationary. If you don't want to use horizontal, you can say stationary inflection point. Of y equal to fx. Then when x equal to 1, so you put in f1, use your GC again, put your x as 1, and you get -8. So you say 1 -8 is local minimum of y equal to fx. Are you okay? Okay. So for part B, you're supposed to differentiate this. F double prime x, 12x squared plus 24x, right? So inflection point means f double prime x equal to 0. So you have 12x, x plus 2 equal to 0. You can straight away factorize. So 12x equal to 0, so x equal to 0. 12 cannot be 0, correct? X plus 2 equal to 0, so x equal to -2. Okay, so you see this value of x happen here. It also happened here. So you know already that is a horizontal stationary inflection point. So this will be non-stationary inflection point. Are you clear? So you don't have to draw the sign diagram. Okay, but I still will draw the sign diagram to help me to know the shape of the graph of fx. So my f double prime x sign diagram. Okay, I have to mark down -2 and 0. So you use your GC to determine the sign. This is positive, negative, positive. Yeah. So I will say that 0. Okay, when x equal to 0, so I find my f0. So I get f0, I get 3. Correct? So I will say 0, 3 is the non-stationary inflection point for y equal to fx. Very careful, you must mention. And when x equal to -2, I don't have to find again, it's here. Okay, so f -2 is 19. So I will say -2, repeat again, never mind. The question want you to do so is the stationary inflection point. Of y equal to fx. Okay, got it? So that is how we determine the nature of the stationary point and the nature of the inflection point. Okay. So if I want to sketch the graph for fx or f prime x or f double prime x, so what I need to do is I just draw the sign diagram of, okay, for this case, I use the sign diagram of f prime x and also f double prime x to roughly know how my fx graph look like. Okay, so I have -2 here, -2 here. Then I have a, okay, go back to that, 1 and 0. Huh? Okay, 0 and here is 1. Okay, so I have negative, negative, positive. And here I got positive, negative, and positive. Okay, so how I analyze? So when I sketch the graph, so I know all these important one. So my fx, I'm going to use blue. F prime x, I'm going to use black. And f double prime x, I'm going to use red. Exam, please don't use red. Huh? Okay, so my fx, so whatever is it, I'm going to use my graphic calculator to help me to do. Because I don't know where is my x-intercept for fx. Yeah, so I'm going to use my graphic calculator to help me, but I know that, yeah, so sorry. So you got your graphic calculator, so your graphic calculator can help you to do. So I'm doing this. So I think I should change my y-axis, not to put it here. Put it a bit here. Yeah. So I'm just trying to tell you that I can do it manually as well. Okay. So I have, -1, -2, important point, 0 and 1. Okay, so these are the important points. So I'm going to, because the inflection point and the horizontal inflection point, so I know that my fx graph will pass through this point here. And here is your 19, -2, 19. 18 or 19 plus? 19, I'm right. Okay, 19, you're going to pass through this point. Okay, and it's going to change the shape at the point 0 and also turn at this point. And this turning point, the coordinate is 1, -8. So it's at the bottom. So my blue one. Okay, now for x less than -2 is going to be convex. That is concave upward, stationary. Yeah, then concave downward. Go like that. Then inflection point at 0, then change shape again, then you go up. So now I can start to draw. You go like that. Yeah, when x equal to 0, what is fx? Just now we find. When x equal to 0, fx is 3. So I have to mark down the point as well. So fx is 3 here. So my fx will pass. So it will be concave, downward. Then after that, from here onward, it go down, then it go up, then it go here. So this is my y equal to fx. Isn't it? You got that? Okay, now my y equal to f prime x. Okay, my y equal to f prime x, it will pass through this point, right? because that is a stationary, and it will pass through this point. And here you see fx is decreasing at the fastest rate. So this will be your lowest point. And it will turn here as well. So there is two turning points here, here, and also here. So you see, negative, from very negative to less negative. So this is your f. Then after that, so in order to turn here, there must be an inflection point someplace somewhere here. Correct? Someplace somewhere here. I don't know where is it. So never mind. That is not important. So you go, then it pass through here, it go up. So this will be your y equal to f prime x. So now your y equal to f double prime x. So it will pass through this point and it will pass through this point, and it's a quadratic. It's a quadratic, and you know that what is the shape of a quadratic? Yeah, it's a quadratic. Quadratic, correct? And it's a positive. Your a is positive. So definitely it will go this way because my f prime x is going up. So it will be very positive to become 0, then someplace somewhere here turn and go up. So this is your y equal to f double prime x. And if you know the property of a quadratic, it should turn at -1 because it's symmetrical. Right? Hello? So in the exam class, listen here. I can give you this given this. Listen, exam, I can say given this. I can give you this graph. Ask you to sketch this one and this one. So please go through your textbook question as well as the sum of the example I give. And I'm not going to talk about increasing with decreasing rate or increasing at the fastest rate. We have done that a lot. So at this point, so I just put one at x equal to 0, y equal to fx is decreasing at the fastest rate. And you want to know the description of this function, please go to Times and download that. Everything is inside there. Okay, any question? Hello? Any question, class? You got a different graph because I exaggerate the graph a little bit. You got a different graph, that means it's something wrong somewhere. I know your graph would seem like crowded together, but the shape have to be like that. Okay, you can change your y limit. Your y maximum, you try to reduce it, you will get the graph some sort like this. Okay? You can try. Yeah. So you just manipulate with it. So I leave it to you to manipulate with the graph. Okay? Can or not? When you sketch, make sure your turning point and everything is at the right place. Should be quite okay. I sketch it quite accurately. Okay. Okay. Thank you, class.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Mm.